Hello guys, welcome to this science paper only presentation, and in today's video I'm going to revise with you Hooke's law and also one question which is coming from forces and velocity. Okay, so the first question is saying a car has a mass of 900 kg. It accelerates from rest at a rate of 1.2 meters per second squared. Calculate Roman numeral number 1. The time taken to reach a velocity of 30 meters per second, 2 marks. So the first thing here, we are going to collect the data. So whenever they use the term rest, this means that the object is starting from 0. So our initial velocity here, which is u, is just going to be 0 meters per second. Then here they have mentioned that this car has reached the velocity of what? 30 meters per second, meaning this one is going to be the final velocity. So we can say final velocity here that we have, it is 30 meters per second. And then apart from that one, it was accelerating at a rate of 1.2 meters per second squared. So this one is going to be our acceleration, which is 1.2 meters per second squared. Then this question is asking us to calculate the what? The time. So meaning the time here we don't have. So now which formula are we going to use, which is going to connect all these variables that we have here? So we can use this formula where we are going to say velocity is going to be equal to initial velocity plus acceleration multiplied by what? Time. Okay. Or if you don't want to use this one here, you can say acceleration is going to be equal to final velocity minus initial velocity divided by what? Time, whichever way you choose. So let's make t the subject of the formula if we use this formula here. So here we are going to balance this one by 1, then cross multiply. So we are going to find that when we multiply a multiplied by t, we are going to get at being equal to velocity, which is final velocity minus initial velocity. Then here we are making t the subject of the formula, meaning we are going to divide by a, even here by a, which is the acceleration in this case. So these two, they are going to cancel each other. Then here we are going to remain with t, which is the time taken. So the time taken is going to be equal to, we have the final velocity, which is this one, initial velocity, then divided by the acceleration. So let's just take the values that we have here. Okay, so time is going to be equal to the final velocity that we have here, it is 30 meters per second. Then the initial velocity here that we have, it is 0 meters per second. So it is very, very important when you're doing the computation, you need also to include the units. Then divided by the acceleration, which is a, that we have here is what? 1.2 meters per second squared. So 1.2 meters per second squared. So 30 meters per second minus 0 meters per second, we are going to get 30. Then divided by 1.2. So let's try to divide. Okay, so we are dividing 30 divided by 1.2. Then the answer is going to be 25. So you can say t, which is the time taken, is going to be equal to 25. Now time is measured in where? It is measured in seconds. So we need to say s, which is going to denote seconds, or if you want, you can just finish by writing seconds. So this one is our final answer for Roman numeral number 1. So let's see the second question. So the second question is saying we need to calculate the force required to accelerate the car at a rate of 1.2 meters per second squared. Now they are asking us the force. So we are going to say force is going to be equal to mass multiplied by what? Acceleration. So now do we have the mass here? Of course, in the same question, this question was saying the mass of the car is the mass of what? 900 kg, meaning this is the mass that we are going to use for m. So where we are having m, we are going to put the mass, which is 900 kgs, multiplied by the acceleration. So we have been given the acceleration, which is 1.2 meters per second. squared. So here is just a matter of multiplying. So we have 900 multiplying by 1.2. Then the answer is going to be 1080. So we have 1080. Now usually force is measured in newtons. So as for Newton, we use capital letter N. So in physics, it is very, very important to include the units whenever you find the answer. So if you just write 1080 without putting the units, the answer is going to be wrong. Okay, let's proceed with question 2b, which is saying a learner carried out a Hooke's law experiment and obtained the following results. So we have table C2.1, and for the first line we have the mass in kgs. Then apart from the mass in kgs, we also have the length of loaded spleen in centimeters. Then apart from the length of the loaded spleen in centimeters, we also have the applied force in newtons. Then the last one is the extension in millimeters. So as you can see, here we have centimeters, then here we have what? Millimeters. So we need to consider these two as special. Okay. So the first question is saying we need to copy and complete table C2.1 by finding values of applied force in newtons and extension in millimeters produced. So they are saying for extension, it should be in millimeters. So now, let's try to answer this one here now. So, let's do an experiment. When they say extension, suppose you have a spleen, like something like this one. So we have the supporting here, or the support. Then this one is going to be the spleen. Now let's imagine that from this spleen, we haven't put any load, and this spleen is having the length of, let's just guess as 3 centimeters, initially without putting anything. Okay, that is initially without even putting anything. Then again, let me draw another one. So as for this one, we are just going to decide to put now a load of 20 newtons. Suppose we put a load of 20 newtons here. Okay. Now, is the length of this spleen going to remain the same, or it is going to change? Of course, it is going to change. It is going to extend. So suppose if the spleen extends from this point up to this point, and it is showing the readings of 15 centimeters. Now, what would be the extension? So in talk of the extension, it's just the displacement of the spleen from the initial position up to the final position. Initially, when it was at rest, it was having 3 centimeters. Now, after putting 20 newtons of load, it has been extended up to 15 centimeters. Now, what would be the extension here? So, for you to find the extension, you are going to say 15 centimeters minus what? 3 centimeters. So, 15 centimeters minus what? 3 centimeters. Then the answer is going to be what? 12 centimeters. This 12 centimeters is going to be the extension. So similarly, on this question, we are going to use the same idea. Suppose we have the mass here of a stone or anything else that we are measuring. Okay. On this part, we have 0 mass, meaning they didn't include anything on the spleen. And the reading of the spleen here, it was showing what? 11 centimeters, according to the units that we have been given here. Okay? Then after adding the mass of 0.02 kgs, the spleen extended up to 12.1 centimeters, starting from where? 11. So let's do an experiment here also. So I'm saying, the first thing here, they add a spleen without putting anything. The spleen leads 11 centimeters. Okay? Then afterward, after putting 0.02 kgs of mass. The spleen extended up to 12.1. So let me also draw that one. So here we have 0.02 kgs of mass. Now from 11 centimeters, the spleen has extended up to 12.1 centimeters. Now what will be the extension? What will be the extension? So similarly, we're just going to do the same thing. The final reading minus the initial reading of the spleen. So you can just say 12.1 centimeters minus 11 centimeters. Then the answer is going to be what? 1.1 centimeters. So this one is going to be the extension. Now, let's see. This question was saying we need to find the extension in millimeters. Now, are these millimeters? So this one is the centimeters. So what are we going to do? We are going to convert this 1.1 centimeters into millimeters. So now one thing that you need to know here is that 1 centimeter is equivalent to 10 millimeters. So when you have 1 centimeter, that 1 centimeter is going to be equal to what? 10 millimeters. So for us to convert 1.1 centimeters, we're just going to put it here. Okay? Then here we can just imagine that we don't have x. So centimeters and centimeters, they are going to cancel each other. Then x multiplied by 1, we are going to get x. Then, let's do this. We are multiplying 1.1 multiplied by 10. Then the answer is going to be what? 11. Now that one is going to be now 11 millimeters. So meaning 11 millimeters is going to be our answer instead of 1.1 because 1.1 is in centimeters. So we can say here we are going to have 11 meters. Now, why are we excluding this one here? When you have zero mass here, then the length of the spleen is 11. What is going to be the applied force? The applied force. So applied force is equal to what? Applied force is equal to mass multiplied by acceleration. In this case, when you're dealing with Hooke's law, we take acceleration due to gravity, which is 10 meters per second. 10 meters per second squared. Now, if we have 0 as the mass, we are going to say 0 kgs multiplied by 10 meters per second squared. What will be the answer for the applied force? It is going to be 0 newtons. So meaning here we are going to have 0. What about the extension? Has the spleen extended on this part here? No. So meaning even the answer here is just going to be what? 0. Okay? Then let's come to the applied force. The applied force, we're just going to use the same idea whereby we say force is equal to mass multiplied by gravity. Okay? Which is the acceleration due to gravity. So if we take the mass of 0.02 kgs, what would be the applied force? So we have 0.02 kgs multiplied by 10 newtons per kgs or meters per second squared. What would be the answer? So we have this one multiplied by 10. Then the answer is going to be 0.2. Now that 0.2 is going to be in newtons. So we are going to say the applied force that we have here is going to be 0.2. So here, do not include the units because they have included the unit here. Okay? So there is no need of you including the units. So let's move on to the next one. If we have the mass of 0.04, what is going to be the applied force? The applied force is going to be so we can just say mass, which is 0.04 kgs multiplied by 10 newtons per kgs. Then the answer is going to be 0.4 newtons. So meaning here, the answer is going to be 0.4 newtons. So they have included the newton here. No need of you putting the Newton here. Now, remember the initial reading of the spleen here is what? 11 centimeters. So if we apply the mass of 0.04 on the spleen, the extension is going to be this one, or the spleen is going to be extended up to 13.2. Now what is going to be the extension? So similarly, we are just going to do the same thing. So we are just going to do the same thing as we have done here. So here we have 13.2. So 13.2 minus what? 11. So when you're answering this question, there is no need of you showing these things here. I'm just explaining so that you understand what I'm talking about. So we have 13.2 centimeters minus 11 centimeters. Okay, so we have 13.2 minus 11. Then the answer is going to be 2.2 centimeters. Now they are asking us to find the extension in millimeters. Meaning even here we are just going to do the same thing. We convert 2.2 centimeters into millimeters. So 1 centimeter makes up 10 millimeters. So we are just multiplying here now. 2.2 centimeters multiplied by what? 10 millimeters. What will be the answer? So we are multiplying 10 multiplied by 2.2. Then the answer is going to be, I guess you can see it, it's 22. Okay. So we have 22 millimeters. So that is what we are going to write here. So we have 22. Then let's come to this one. If we apply the mass of 0.06 on the spleen, what is going to be the applied force? So the applied force, we need to do the same thing, whereby we say force is going to be equal to the mass. In this case, it is 0.06 kgs multiplied by 10 newtons per kgs. Then the answer is going to be 0.6 newtons. So we have 0.6 newtons. Now, if we apply 0.6 newtons or 0.06 of mass on the spring is going to be extended from 11 up to 14.3. Now, what will be the extension? So the extension, just say 14.3 centimeters minus 11 centimeters. Then the answer is going to be what? 3.3 centimeters. Similarly, you convert this 3.3 centimeters into millimeters. So if you want to convert this one into millimeters, just get 3.3 centimeters and multiply it by 10 millimeters divided by what? 1 centimeter. So that centimeter and centimeter can cancel each other. Then here when we multiply 3.3 multiplied by 10, we are going to get 33 millimeters. So that is our extension that we have. So we can just say 33 millimeters. Then let's come to this one. We have the mass of 0.08 and we are finding the applied force. So 0.08 kgs multiplied by the accent due to gravity, which is 10 newtons per kgs. Then the answer is going to be 0.8 newtons. So we have 0.8 here. Now, if we apply 0.8 newtons on the spleen or 0.08 kgs of mass on the spleen, the extension is going to be, or the spleen is going to be extended from 11 up to 15.4. So now to be the extension here. Similarly, you're going to say 15.4 centimeters minus 11 centimeters. Then the answer is going to be 4.4 centimeters. Then you convert it into millimeters. It is going to be 44 millimeters. So you can just say 44. Okay? So sorry for including the millimeters here. Then the last one, if we have 0.10 kg of mass, what would be the applied force here? So we are multiplying 0.10 kgs multiplied by 10 newtons per kgs. What is going to be the force? So the force here is just going to be 1 newton. So here we have 1. Now if we apply 1 newton, the spline is going to be extended from 11 up to 16.5. Now what is going to be the extension? So we are going to say 16.5 centimeters minus 11 centimeters. Then the answer is going to be 5.5 centimeters. Similarly, you convert this one into millimeters, then you're going to get 55 millimeters. So we have 55 here, which is going to be the final answer. So let's see the next question. But as for this one here, since the question was saying we need to copy and complete the table, so meaning you need to copy and complete the table using the graph paper. So let me just copy what we have answered here on this graph paper. Okay, so as for question B, it is saying we need to plot now a graph of applied force against extension in millimeters, 4 marks. So we are plotting the graph of the applied force in newtons against extension in millimeters. So whenever the question is saying like this, meaning what is going to come first should be always in the y-axis. Then what comes at the end should be always in the x-axis. So this one is for the y-axis, this one for the x-axis. So let's plot the graph. Graph, we are only interested on two things, the applied force and also the extension. Now, it is very, very important to know how to draw a graph and the materials to use. The first thing, you're supposed to use a ruler. Then apart from a ruler, you need also to have a pencil. And in addition, if you want, you can also have a rubber. But one thing that you need to know is that every graph should have the title. So I'm going to start with the title. Since the question was saying we need to plot a graph of applied force against extension. So we are going to say the graph of applied force against extension. So that is how you're supposed to write the title of the graph. And if you write in small letters, you're supposed to underline. Okay. So let's come to this one. So we have the applied force in the y-axis, extension in the x-axis. Now let's see what we have here. So we have 0 up to 1. So which length are we going to use here? So the length that we are going to use here is just going to be 0.2, 0.2, 0.2, 0.2. So if we say 0.2, 0.2, 0.2, this box here, starting from this point here up to this point, this one is a 2 centimeter box on the graph paper. Now this 2 centimeter on the graph paper, it is going to represent 0.2. So if we start from this point where we are going to say this one is going to be 0, meaning the next one is going to be 0.2 for the applied force. So we have 0.2. The second one is going to be 0.4. The third one is going to be 0.6. The fourth one is going to be 0.8. Then the last one is going to be 1. Okay? That is the applied force. So you need to write applied force. So we have the applied force. This applied force is in newtons. So you need to write everything, applied force in newtons. Okay? Then apart from that one, what is remaining here is now the extension. So according to the numbers that we have for extension, we have 0 up to 55. So which range are we going to choose here? So you can just choose 2 centimeters is going to represent what? 10. 2 centimeters is going to represent what? 10. So if we say we are starting from 0 here, the next one is going to be 10, 20, 30, 40, 50, 60. Because here, we are ending on where? 55. So let's do that. This one is 60. So now we need to know, since as for the applied force, we have just taken the numbers the way they are. The range is just arranged in order like that. But as for the extension, they are not arranged in order. So what are we going to do? We need to know what each small box in a 2 centimeter is representing. So we have, in a 2 centimeter, we have 10 small boxes. Okay, so we have these small boxes here. Now we need to know what each box is representing. So if you want to know what each box is representing, just get the number that you have used here, which is 10, then divided by the number of small boxes that you have. So in this case, we have 10 boxes here. So we are going to divide by 10. Now 10 divided by 10, we are going to get what? 1, meaning each line or each small box is representing what? 1. So let's come up with the graph now. So the first thing that we have here, we have 0, 0. So 0, 0 is somewhere here from the origin. So we are starting from the origin. Then the next one is going to be 0.2, 11. So since this one is 10, meaning the next one is going to be what? 11. Now it is 0.2, 11, meaning the point is going to be somewhere here. So we have a point here. Then the next one we have 0.4, which is this one, 22. So if this one is 20, where is 22 going to be? So 22 is going to be somewhere here. So we can say 20, 21, 22. Now it is 4. It is 0.4, 22. So it is going to be somewhere here. Because this one is 0.4. Then if we start from this one here as 20, 21, 22. Okay? Then the next one, 0.6, 33. So 0.6, 33, 0.6 is somewhere here. Now 33, since here we have 30, meaning this one is going to be 31, 32, 33. 33 is going to be somewhere here. Okay? I hope we are together on this part. Then the next one we have 0.8, which is this one, 44. So if this one is 40, so we need to count where 44 is. So if this one is 40, this one is going to be 41, 42, 43, 44. That is where 44 is. Then the last one, we have 1, 55. So if this one here is 50, so if this one here is 50, and this one is 1, so we are going to say we have 1, 55. So 50, 51, 52, 53, 54, 55. So 55 is somewhere here. So that is where we are going to have 55. So now let's try to draw the lines. So even here we're supposed to draw a line. Okay. So after drawing the lines, so here we have forgotten to put extension, so we can also include this one as the extension. And this extension should be in millimeters. So extension in millimeters. Then let's just join these points, starting from this 0, 0 up to 1,55 by using a loop, because the points are in a straight line. So if the points are not in a straight line, make sure that join the points which are in a straight line by using a loop, and those which are not in a straight line, use your free hands. So we are joining them, starting from this point. Just need to draw a smooth curve like this. Okay. So So that is what we are going to obtain here. So let's continue with our questions. So the next one is saying, from the graph, we need to determine the spleen constant. So from the graph, we need to determine the spleen constant. So let me just give you the formula that you're supposed to use when you're finding the spleen constant. So force is going to be equal to the spleen constant multiplied by E, which is going to be the extension. So we can say this F here is going to represent the force applied where in newtons. Then the spleen constant, it has no units, so we can just say this one is going to be the spleen constant. Spleen constant. The spleen constant is same as the gradient. Okay? Then this one is going to be now the extension. In this case, the extension, we have been given the extension in millimeters. So let's just use this formula now for us to find the spleen constant, which is K. So we are going to choose any point in the graph, then we can find the spleen constant. So if we say we choose this point here, where we are going to say, okay, so we are going to say this one is going to be 0.6. So this one is going to be 0.6, 33. Okay? Now 0.6, 33, meaning here we are having the applied force. 0.6 is going to represent the applied force. Then 33 is going to represent the extension. Okay, so we have the extension up to this point, which is 33. So now by using this formula, we are just going to say the force that we have, it is 0.6 newtons. Then the constant spleen we don't have, or spleen constant. Then the extension, it is 33 millimeters. Then when we multiply here, we are going to get 33K. Then here it is just 0.6 newtons. So dividing by 33, even here by 33, 33 and 33, they are going to cancel each other. Then K, which is the spleen constant, it is going to be equal to, so we have 0.6 multiplied by, let me say divided by 33. Then the answer is going to be 0.018. Okay, so we have 0.018, 18 is going to be our answer. Or if you want, you can just say the spleen constant is going to be equal to 0.018, like that. So that one is the answer. Okay, let's continue. Then question D, Roman numeral number 1 is saying, did the spleen reach its elastic limit? So in talk of elastic limit, this one is just the maximum displacement of an elastic material. So when an elastic material exceeds the elastic limit, it is going to undergo permanent deformation, whereby it is not going to go back on the initial length or initial position. Now, according to the curve that we have here, this means that this spleen didn't reach the elastic limit. Okay? So we are just going to say the spleen didn't reach the elastic limit. That's the answer. Or if you want, you can just say no. Okay? It's up to you to say didn't reach the elastic limit, or you just say no. Now, why are we saying the spleen didn't reach the elastic limit? The next one is saying now we need to explain the answer for us choosing that the spleen didn't reach the elastic limit. So the reason why the spleen didn't reach the elastic limit, this is because the curve of the graph is straight. That's the answer. So you're just going to say because the curve of the graph is straight. Okay, now let's come to this one here. Since the curve here is straight, and then we are saying the spleen didn't reach the elastic limit. Now, when is the spleen going to undergo permanent deformation? So when the spleen undergo permanent deformation, meaning it has exceeded the elastic limit. And how is the graph going to look like? So if you have a graph something like this one here, graph is not straight, meaning the graph or the spleen, I may say, is undergoing permanent deformation. You may also be told to show where the elastic limit of the spleen is starting from. So now, how do you show that one? As you can see from this graph here, starting from the initial up to this point, the curve is straight. Then from this point here up to this point, the curve is not straight. Meaning, from this part up to this part, that is where now we are having the what? The elastic limit. Okay? Meaning, on this part here, the spleen is undergoing the permanent deformation. Meaning, it is not going to go back onto the initial position. And the last thing is on this part here. It is not always that you are going to convert the units of the length of the loaded spring from the centimeters into millimeters. If they have given you centimeters here, even here centimeters, meaning just go direct like that. Then you answer the rest of the questions. So that was the last one. Thanks for watching and see you next time.